Hello, everybody. Welcome to our Algebra 2 class this week of April 27th. It's the Monday that we're going to start this unit on systems of equations. This should be somewhat of a review for most of you from Algebra 1 especially. And we're going to go through a bunch of different ways to solve a system of equations. And we're going to start off by solving by graphing. So the best way to use graphing, or more specifically, when do we want to use graphing, is when we see that we have really two equations that look like we have the y by itself. A lot of times we call that slope-intercept form for us in Algebra 1, and specifically with that, we know that our m is our slope. So that will allow us to eventually figure out how to move on the graph. And a good starting spot is our b values here. This is our y-intercept, which hopefully it's a little bit of a review for you on that one, but usually it's some sort of 0, y value. We'll plot that point first and then move from that on using our slope. So I want to take a look at two examples here specifically, just for practice sake, very basic stuff from Algebra 1. I have two equations up there. It's a system. I got y is equal to 4x plus 3 and y is equal to negative x minus 2. And I'll go ahead and start off by doing y is equal to 4x plus 3 first. From that equation, we know that our slope is 4. We could rewrite that if need be. It might be helpful to write it as a fraction. So we see 4 over 1. It's a positive number, so we're going to move from that up 4 and to the right 1. We're also going to probably start off with the y-intercept here. And the y-intercept here is 3. It's positive 3 on the back end. You can see plus 3 right there, which means we'll go ahead and we'll start graphing this using our point 0, 3. So we'll start off with point 0, 3. We're supposed to go up 4 and to the right 1. However, you can see with the graph here specifically on the screen that we're going to run out of room. So we'd go up 4 and to the right 1, and we're going to run out of room. We can also do the opposite of that. So if we're going to go up 4 to the right 1, the opposite of that would be to go down 4 and to the left 1. So we can always do that if we run out of room. No big deal. We do want to fill up our graph as much as possible. So we'll go down 4, 1, 2, 3, 4, over 1. There's a dot right there. I'll go ahead and put that on there. Same exact thing. 1, 2, 3, 4, and to the left 1. I'm going to try my best here to make a line. See how it goes. And let's see how this goes. Yeah, not too bad. Not too bad right there. We'll go ahead and then do the second one. Y is equal to negative x minus 2. Again, since slope-intercept form, we have the y by itself. Both equations, y by itself here. So a little bit leaning towards graphing here is probably one of our options that would be best suited for this situation. Again, I'm looking at the slope. It's a little bit confusing because we see a negative x. So what that means is we have that coefficient of negative 1. All right, so if we had to write that out as a fraction, or excuse me, it would be negative 1 is our slope. And if we wrote that out as a fraction, it'd be negative 1 over 1. Always kind of want to move right first when it comes to like looking at a fraction. The negative symbol kind of refers to us going down first. So when I see negative 1 over 1, I'm thinking I'm going to go down 1 and to the right 1. We could, as we did in the last problem, it might come out to be the fact that we could do the opposite of that. So instead of down 1 and to the right 1, we could also go up 1 and to the left 1. We'll see if we get there. But all going to start off with our y-intercept. So our y-intercept here is negative 2. Which means we're going to start off by graphing this at the point 0, negative 2. So we'll go ahead and put a dot there at 0, -2. There are going to be a lot of dots on this one. Down 1 and to the right 1. So down 1, right 1, down 1, right 1, down 1, right 1. Hopefully you can start to see here the negative slope involved for this line. We'll go the opposite to fill out our chart. And we're going up 1 and the left 1 with that. Let's go ahead and make a line as best as we possibly can. And we have that right there. Now, when we have a system of equations, and especially when it comes to graphing, anytime we have a system, we graph the lines and they cross at one location. That means we're going to have one solution here. We'll see some parallel lines with no solutions. We'll see some overlapping lines with an infinite amount of solutions. But in this particular case, we only have one solution because there's only one location where our graphs are crossing, and it's right there. We can see the graphs are crossing at that location, and that location for us here would be -1, -1. So the solution to this system of equations, the point that we could plug into both equations in order to see our two equivalent statements would be -1, -1. Next up, I did want to throw in one of these examples here. We have y is equal to -1, which is kind of a weird looking equation. As simple as it may look, it is kind of weird to graph, or it's something that sometimes trips up Algebra 1 students, especially. And then I have y is equal to -5/2 x plus 4, which looks a little bit more like the ones we just did. So we will start off, let's go ahead and just start off with the easier of the two, where it's kind of familiar with what we just got done doing. So I'll start off doing it with this one. Do the y-intercept first, since that's still going to be the first point we graph. So for this one, we see that our y-intercept here is 4. We'll start this line off at the point 0, 4, which is right there. We'll look at the slope, which is our coefficient for x. In this situation, we've got the y by itself. It's in slope-intercept form. -5/2 is our slope. That negative symbol, again, remember, refers to it going down first. So we'll go down 5. We'll always start off this process here by writing out that we're going to go to the right 2. Okay, now it's possible in this situation, although you could see that we're going to go off the graph here, that if we had to, we could do the opposite of that. So we could go up 5 and to the left 2. But we're not going to do that in this case because we're going to run out of room. So we got down 5 and to the right 2. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. We're even off the chart on this one. That's all right. Let's go ahead and do the best we can here at drawing this line. I got a little off here. Tilt it, and there we go. That looks a little bit better. Now the next line here is y is equal to -1, which looks simple, but we kind of have to think about this. And we know that, especially back in Algebra 1, that we had things called horizontal lines, and we had vertical lines. Our horizontal lines, we know, usually ran like this. They were flat, and our vertical lines went up and down just like that. And we're taking a look at y is equal to -1, and that's kind of a big deal. It might actually kind of help us with graphing it. So that's the only information we have for that equation. I'm going to go ahead and I'm going to put a dot wherever I can figure out where y is equal to -1. So I do not want to go to a point where it would be right here. That's not a point where y is equal to -1. That's our x value is -1. Right here is a location where y is equal to -1. In fact, that spot, the first dot I drew there, was 0, -1. It's a graph, though, and that's not the only location that could have a value of y being -1. So I'm going to try to find as many dots as possible, and then hopefully that will kind of help us figure out where it is exactly that I want to draw this line. So other spots on this graph that have a y value that's -1. 1, -1, 2, -1, 3, -1, -5, -1. And you can hopefully see by this point the pattern that's here is that um, if we see a y value by itself, there's no x value involved with the problem at all. We have y is equal to some sort of number. We're going to have ourselves, in this case, a horizontal line. It's a flat line. So, um, you know, there's plenty of things that go into that. A horizontal line here has zero slope. A vertical line would have undefined slope. But again, for the purposes of what we have going on here this week, let's go ahead and kind of just call it a day there by figuring out where are all the points that y would be equal to -1. All of those points, like we talked about, do have a y value of -1. Again, it's a system of equations. Could have no solution if the lines are parallel. Could have infinite solutions if they were overlapping. But in this case, there is one particular location where those lines are going to be over one specific spot where they are crossing is what I meant to say. And that spot here would be the point 2, comma, -1. And for this graphing problem, that's going to be our solution. It kind of makes sense that if the first equation said y is equal to -1, that our y value would have to actually be y is equal to -1. So 2, -1 makes sense, generally speaking, just by looking at that first equation.